Hi, this is Ms. Logan. Today I'll be talking about vectors in 1D and 2D. Anytime that I have a vector in 2 dimensions, I always need to break it up into my x and my y components. So remember, my x is on my horizontal and my y is in my vertical. Now, most problems will give us an angle and they'll give you a hypotenuse. So it might be something like 3 meters per second. So we need to actually use trig to help us out. So before we kind of dive into examples of this, I'm going to go through SOHCAHTOA. So sine theta equals opposite over hypotenuse. Then we have cosine, which is adjacent over hypotenuse. Remember, opposite is where the angle shines to. Adjacent is what is right next to it. Last, we have tan theta, which is opposite over adjacent. So another problem we may come into is we have a triangle, and then I have 2 sides. Maybe this side is 3 meters, this side is 4 meters, and I found my resultant. So often you'll be asked to figure out this angle. This is where I need to use my inverse functions. So tan inverse of my opposite over my hypotenuse will give me my angle. So I recommend referring back to this slide often when we work on our vectors during this flipped lesson and in class. So from last chapter, a vector has a magnitude and direction. So this is like 3 meters per second west, or it could be 3 meters per second at 30 degrees northwest. So we can have vectors that go in 1 dimension, or we can have 2 dimensions, so they're going at angles. And that's really going to be the focus of this chapter. So our resultant is the sum of 2 or more vectors. So for example, if I am going 3 meters to the right, and then I turn around and go 4 meters left, my resultant would be -1 meter. We know that from last chapter, but we really didn't focus on the vocabulary. So my resultant is the sum of 2 or more vectors. All right, so let's do a problem adding vectors in 1D. So I walk 10 meters north, and then I turn around and go 12 meters south. So my resultant, I need to add these together. So 10 is going positive, my 12 is going negative. So I'm going to have -2 meters for my resultant. So if I am looking at something in 2 dimensions, which is the focus of this chapter, everything must be broken down into the x and y directions. So in this problem right here, something is moving 4 centimeters north, and then they're moving 4.5 centimeters west. I can't just add them together. If I add them like this would not be correct. They're in 2 different dimensions. I cannot add them together. So I need to use Pythagorean's theorem. So a squared plus b squared equals c squared. So I can do 4.5 squared plus 4 squared equals c squared. So I should get 66.25 equals c squared. Now I'm not done yet. I need to take my square root on both sides. So this will give me 8.14. Now, I may think I'm done, but I'm actually not. I have no direction attached to this. So I need to use some trig functions to figure out this angle right here. Now, our previous slide, I talked about using the inverse of tan, and this is what I recommend using most times. So I have the inverse of tan, then my opposite, which is 4, over my adjacent, which is 4.5. That will give me an angle of 41.63 degrees, and I'm going south of west. So here's a common problem that we'll see in a lot of our 2D kinematics problems. So we're going to be given a velocity at an angle, and we have to figure out my x and my y components. So this is where I'm going to be using my trig identities. So I need to figure out my x side and my y side. Well, let's think about what we know. I have my angle, I have my hypotenuse, and then my x side is my adjacent. So if I have my adjacent and my hypotenuse, I can use cosine. So cosine of theta equals adjacent over hypotenuse. And now it's just really plugging numbers in. So my cosine of 30 degrees equals my adjacent over my hypotenuse, which we know is 24.3. So for my answer, after doing my cosine and then multiplying both sides by 24.3, I'm going to get my adjacent is 21.04 meters per second. So we're going to do something very similar on the other side. So on my y side, this is my opposite, and then I have my hypotenuse. So opposite hypotenuse, that's the so I'm going to use sine theta equals opposite over hypotenuse. So I have sine of 30 degrees over opposite over 24.3. So for this, I'm going to get 12.15 meters per second. So this is a very common problem that we're going to be looking at this unit when we're talking about angles. So it's really important to remember that going back to our notes during our flipped lesson is going to really help during this unit. Make sure that you took notes during this flipped lesson and you complete the Google form.